Time is heavily used in programming and the database. How to play with time in Go. This is what I'm going to talk about in this video. So first, let's clarify two concepts. One is time, which means an instant or a moment. The other one is duration, which means a period of time. So how to get a time in Go? First, we can use time.now, which returns the current moment in runtime. Secondly, we can use time.date and pass everything we need in a time. So year, month, date, hour, minute, second, nanosecond, and time zone. The third way is to convert from milliseconds in Unix format. For example, here it's a millisecond since January the 1st, 1970. I got it from JavaScript date now. The first approach is to pass it from a time string. So you pass the layout string as the first parameter and the extra time string as the second. You might wonder why 2006 here. That's something I'm going to cover in the next 3 slides. So basically, in the time package for both parse and format, we use something called layout string. But that layout string is a little bit different from what we are familiar with, like this one, right? Instead, it uses 2006, January the 2nd, 3 p.m., a very detailed time string, but you might be wondering where all those fields comes from. Actually, there's a full table of possible values for all those fields. Don't be terrified by this table. I'll teach you how to memorize this. So all you need to remember is this rainbow colored time string in American format. This is the month, date, hour, minute, second, year, and time zone, right? 1, 2, 3, 4, 5, 6, 7. Plus, we have PM here, and the minus sign means west of GMT. So that's all you have to remember. So January the 2nd, 3 p.m., 4 minutes, 5 seconds, 2006. And it's minus 7 for time zone, which means MST. The only thing you want to remember that January the 1st, 2006 happens to be Monday. Alright, that's all about how to get a time, how to pass a time. The next, how to get a duration. There are 3 ways to do it. One is to multiply integer with a unit. We have units like time.seconds. The second approach is to subtract a time from another. And the third one is to pass a duration string. So you can use units like hour, minute, second, nanoseconds, microsecond, and milliseconds. Alright, so that's for practical use. Now let's dive into the data structure of time to see how it is represented in Go. Let's look at the history first. So before Go 1, this is how the time structure looks like. So you can see that it has a lot of details like year, month, day, hour, minute, second. You can notice that the position back then was second, right? Which might not be enough. That's probably why they make changes in Go 1. You can see that there are less fields but more comments. The first change is that instead of having all those year, month, dates in the struct, now we just have the seconds. It's the seconds since January the 1st and year 1. And now we have nanoseconds as the position, and everything related to time zone was moved into a struct called location. And next in Go 1.9, there are even more comments adding to this struct, and the second and nanoseconds are removed. Instead, we have the wall and the extension. It's pretty hard to understand just looking at the few names. I translate those comments into the next 2 slides. There are 2 modes for this data structure. One is wall clock mode, the other one is monotonic clock mode. Both the wall and extension fields are 64-bit long, and the highest bit of wall indicates whether the extension field is monotonic time. If it is set to 0, which means it's a wall clock mode, then the next 33 bits of wall will be empty or 0, and the last 30 bits of wall will be the nanoseconds, and the entire extension field will be the seconds since January the 1st, year 1. While in monotonic clock mode, the highest bit of wall is set to 1, and then the next 33 bits represent the seconds since January the 1st, 1885. I guess the reason for 1885 is because the International Meridian Conference was held in October 1884, and it took effect the next year. The rest of 30 bits is still nanoseconds, that's not changed. Then the entire extension field will be filled with monotonic clock reading. So let's review the data structure again. The difference will be the highest bit of wall and the next 33 bits. And the content of extension. The nanoseconds here remain the same, right? When a seconds is stored in extension, the baseline is generated first year 1, while in monotonic mode, the baseline is generated first 1885. Okay, that's all about the data structure. Now let's look at why go added monotonic clock at the first place. The root cause was the leap second at the beginning of 2017, and it turned the clock back by a second and made that piece of code return negative duration, which is expected to be non-negative. So it broke the code and resulted in a DNS outage. While monotonic clock is the cure for this kind of situation because it never goes back and is not subject to change for clock sync or reset. So that's why Golang added monotonic clock into time package in Go 1.9, and they keep the original API and made that change transparent to the users so that they don't have to change any code on their side. We have talked about 4 methods to create a time, but more than only time.now will set the monotonic clock. The reason for that is because we only have access to the monotonic clock reading at this very moment. And for the same reason, whenever you try to modify the time, the monotonic time will be discarded. Monotonic time only makes sense when you try to see the difference between two times. So it's useful in areas like comparison and getting durations. So functions like after, before, equal, and subtract will use monotonic time if both T1 and T2 are in monotonic mode. Just in case you're curious about the system-level API to get monotonic clock, for Linux and Darwin, it uses API clock get time, while for Windows, it uses query performance counter. You can Google those two if you want more details. There are several ways to control the timing of execution in Go routine. First, you can use time.sleep to pass the current Go routine for at least the duration D. Or you can use the new timer method to return a timer that contains a channel of time. Or you can use the shorthand method after to return the channel directly. Or even further, you can forget about the channel and use afterfunc to specify a function to run after that duration. Those three are similar to setTimeout in JavaScript. There is also a counterpart of setInterval in JavaScript. It is called newTicker. It returns a ticker. A ticker is similar to a timer. It also contains a channel of time. The difference is the signal in this channel is repeated. It's not recommended to use the shorthand method tick because it discards the ticker and returns the channel directly, so there's no way to stop a ticker, so there will be a memory leak. Alright, that's all I want to talk about time in Go. I hope you like it, and please subscribe to my channel if you want to dive into more Go standard libraries with me in future. Alright, see you next time.